let's start the session 5 minutes later.
Good evening, everyone. A very warm welcome to all of you joining us for the second session of Ingenuity 3.0, organized by the IEEE Women in Engineering Student Branch Affinity Group of the University of Malta. I'm Dulmini Athanayaka, and I have the pleasure of being your host for today's session. Ingenuity 3.0 is a platform dedicated to bridging the gap between academia and industry by bringing together experienced professionals and aspiring engineers. Through this series, we aim to inspire innovation, encourage continuous learning, and expose participants to emerging technologies shaping the future. Today's session is titled From Zero to Cloud. Introduction to Cloud and Designing a Metro e-ticketing System on AWS. Before we begin, let us officially commence today's program. It's my pleasure to warmly welcome you all to today's meeting. Thank you for your presence, and I wish everyone a productive and successful session.
Yeah,
Here are,
we can.
here are
Yeah,
some recaps from our previous sessions. So, cloud computing has become the backbone of many modern digital services, enabling businesses to build scalable, reliable, and efficient applications. Today's session will introduce the fundamental concepts of cloud computing and demonstrate how the concepts come together in designing a real world metro e ticketing system using AWS. Whether you are just beginning your cloud journey or looking to understand practical system design, this session promises valuable insights for everyone. And now, it's my pleasure to introduce our distinguished speaker for this evening. Our speaker, Mr. Anjana Patirana, is a software engineer at Crane with experience in cloud technologies and software development. Today, he will guide us through the fundamentals of cloud computing and share practical insights into designing a real world metro e ticketing system on AWS. Please join me in giving a warm virtual welcome to Mr. Anjana Patirana. Over to you, sir.
yeah. Thanks, Bilmini. Hope I'm audible to everyone.
Yes, sir.
Yeah, okay. So, I'm Anjana Patrina. I'm a software engineer at Crane. So, for the today's session, I will be conducting the session for you. Let me share my screen. Yeah. I hope my screen is also visible to everyone.
Yes, sir.
Okay, nice. So for the today's session, first I want to thank IEEE of University of Monaco for inviting me for this session. So it's a great pleasure for me to share the industry insights, especially as a engineer working for a US based product company. So it's a very pleasure to share our industry experience with you. So for the today's session, I will be giving an introduction to cloud. So the today's session would be on this topic from zero to cloud. I hope, as the information I received from your representatives, the session would be mostly participated by the second and third D undergraduates. So that's why I kept this topic here from zero to cloud, and also we will be going through introduction to cloud and designing a metro integrated system on AWS for basically for the scenario where metro buses that were introduced to Sri Lanka recently. We will be going through the use case there, and we will be we will be designing a cloud infrastructure for to facilitate this metro integrated system on AWS. Okay. So before moving on to more details, I want to share some insights about Crane. So we are a US-based product company, and we are a startup actually, and we are a global company. We have teams from US, India, Sri Lanka, Nepal, Germany, and Ukraine. So currently we have people from all those countries, and we are a global team. and we are a product company. Uh, we are developing and maintaining a product for US construction domain, basically for construction supply chain management. So we are a construction supply chain management software uh, team for specifically for US region. So currently we have customers from USA and Canada, and we are AI driven company. Basically, we have many AI involved and AI driven features in our application to automate the most of the construction supply chain management documentation related processes. And also we are a very fast paced developing we have very fast paced development cycles, and we have exposure to most of the tools and technologies in the industry, the latest ones, from agentic engineering to project management tools to MCPs to integrations. We use everything. What's introduced today, we will be using it by tomorrow. That's about the culture at Crane, and we are a company with a great culture. So if you guys are interested, you can follow Crane Instagram. You can follow Crane on LinkedIn, and you can keep your eyes on the opportunities that will be opening in future at Crane. Okay, so moving on to the session. So for today's session, we will be going through these topics. We will be discussing intro to cloud computing and also introduction to AWS. And I will be going through some of the AWS tools. I will teach some of the AWS tools to you. So then we will be designing integrity system for Metro by considering by using the tools that we learn in this third section, right? So why cloud computing? So cloud computing, early days actually, without cloud computing, the software development process was kind of difficult. It was kind of challenge. There were many challenges. um, uh, First one is, if we are developing software, we had to buy and maintain and keep servers for to deploy our application. So in office premises or anywhere, we had to keep servers. We had to maintain computers and servers to deploy our application, and we had to guess the capacity. So if it is a software that has high demand on, let's say, seasons like December or the Christmas season, we had to guess the capacity, and before that season arrives, we had to increase our resources to facilitate the traffic that would be coming on that season. But this is purely on guesses, and if the resources we facilitate are less, uh, our customer satisfaction won't be great. Application won't be responding at most of the instances. And also, if the resources are very high, we have plenty of resources allocated, it would be a cost for us because it's a waste of money. So that was a issue in early days. And also scaling the application was challenges on those days. Uh, yeah, it was challenges those days because we couldn't scale as we wish right away. Because of the same issue, we had to acquire related servers, we had to do upgrades, we had to maintain hardware hardwares for the service. And also there was a long procurement cycle to acquire the service as well. So it's like we had to use our own power, electricity and cooling systems, security. And also, although we are although this uh, although we are developing software, all days, in those old days, we had to keep a separate operations team and a team to manage the servers. So that's the era 20 or 25 years ago, by this date, right, where cloud computing was not there. But and also, those days there was a huge barrier to enter to the industry, by developing a software, because to deploy the software, the companies had to afford the service. So there was a barrier for entry, entry companies, very small startups and companies. Only the big companies could win the game. That's the story about the old days of cloud computing. Let me just switch off my camera for a minute. It's the brightness is very high. Yeah. 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 Let's continue. Then why cloud compute? Yeah. So what is cloud computing? So around 20 or 25 years ago, um, this cloud computing concept was evolved. So with cloud computing we don't actually manage or maintain the hardware related to hosting. So basically we rent computing power over internet from the on-demand services or on-demand cloud providers like AWS, Google Cloud, or Oracle, or Microsoft Azure. So they are the kinds of the cloud computing, cloud service providers. And with cloud computing, actually, we pay for what we use. We don't pay for idle time, and we don't need to maintain the burden for the uh, maintaining the hardware resources as well. Scaling up or scaling down is very easy. So before cloud computing was introduced, earlier days we had to upgrade our hardwares, the computers and servers on premise. But with cloud computing, it's just a click of few buttons, so we can scale up or scale down our services. And we can launch a service in very easy. Earlier days we had to acquire hardware component servers, and then we had to set up them, network them. But now with these cloud service providers over internet, launching a service very easy. And the cloud service provider like AWS, Microsoft Azure, or the GCP provides the hardware, and they maintain the hardware for us. They have the storages and databases on their data centers. We don't need to think about those hardware burden. We only take the service from them. So they are the people uh, who are maintaining those hardware resources on the data centers. And with this cloud computing, even you, the undergraduate students, can develop a software and deploy, because you don't need to acquire or maintain hardwares. You can use the cloud providers. So uh, the barrier for the entry to the industry was kind of reduced with this cloud computing. So it's like electricity we use. Cloud computing is like electricity we use. In our houses, what we do, we just take the electricity from the grid, and we pay for the use, we pay for the units we use. In the same way, cloud computing, we take the cloud facility from the cloud service providers over internet. So the cloud providers are like AWS, Azure, Oracle, or GCP. So we pay for the use only. We don't need to have a uh, premise on premise servers. So in houses we don't have a power plant, right, to generate the electricity. So in the same way, with cloud service providers, we don't want to maintain or keep servers on premise. We can use the cloud service providers. It's the same like the electricity we use. We just pay for the use. We take the service through the internet. That's it. So these are the major cloud providers. We have AWS. AWS is the most AWS keep the significant percentage of the industry on cloud computing. Yeah, AWS is the lead actually. Then we have Microsoft Azure, we have GCP, Google Cloud Platform, and we have Oracle Cloud, IBM Cloud. So in today's session, we will be focusing on AWS services. So what is AWS? AWS is the pioneer and also the largest cloud provider at the moment worldwide. So AWS was launched in around 2006. It's a part of the Amazon Group, which is led by the Jeff Bezos. So it's also the same subsidiary of the Amazon group of companies. And in AWS, Amazon Web Services, there are more than 200 plus services. So all are on demand. Many of them are managed services. We can uh, use those tools over AWS. With AWS, we actually pay only for what we use. We don't pay for the idle time. The larger or the most famous users of AWS are Netflix. So Netflix run on AWS, and also Airbnb, NASA, and also many governments of all around the world. They run on AWS, and also when it comes to Crane, it's our company. We are also running on AWS, and when based on my previous employments as well, almost all the projects I worked on, they were running on AWS. So AWS is the leader of the industry right now. So how AWS is organized? So actually AWS have AWS regions. So you can actually take notes from this point onwards. If you have any questions, please raise the questions on the chat. I will answer them after the session. So AWS have the regions defined worldwide, for US, Europe, Asia, uh, Southeast Asia, Africa region, Australia region. So they have regions defined, and in regions they have availability zones. In these availability zones, they have the data centers. So let's say, so there's a region for Asia near Mumbai. There's availability zone there in Mumbai. So that's the most closest one to Sri Lanka. So there they have a data center, physical data center. So they have the all the servers and the computing power, hardware resources at that availability zone. So we are that's the most closest one for us. So we can um, pick that availability zone and the region, because if we are developing a software for users for Sri Lanka, we can select that. But if we are developing a software for, maybe let's say, for US, we should select a region that is more closer to uh, that the customers that we serve. So if it is US, we should of course select a region closer to US. Basically, there are several regions in US. We can select US East or US West regions there. So we should pick a region close to our customers. That's the point here. And AWS is built across the availability zones, so it's a decentralized network. So if in case any availability zone or a region goes down, if there is a failure, others will work for us, because the whole network, AWS network, is decentralized all over the world. So failure at one availability zone won't affect won't affect significantly for the users worldwide. And when it comes to the service categories that we have under AWS, we have computing services. They can run code, and also we can rent the servers as well. So EC2 is a tool we can use to we use to get the servers, maybe Linux server or Windows server, Mac server, maybe Fedora or Ubuntu. We can uh, take from these EC2. We can actually create those from EC2 service, EC2 instances we can create. And Lambda is also a computation related service. We can run code there. Let's say if you need to write a simple CRUD APIs, so you can basically write them on this Lambda. You don't need to actually deploy a server for that. If that is a very simple code for execution, you can use Lambda. And for storage, we have S3 bucket, and also EBS, Elastic Block Store. Those services in AWS we can use for the storages. So you can actually take notes on these tools. Just try to take notes on these tools so you can refer to them later. On databases, we have on AWS we have relational and non-relational database services. So RDS is a service for relational databases, so we can actually create instances of MySQL or maybe PostgreSQL using this RDS, relational database management system, relational database systems, RDS. And also DynamoDB is a database Using DynamoDB service provided by AWS, we can create um, 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 non-relational database instances. It's a similar thing like MongoDB. So DynamoDB is a non-relational database service provided by AWS. And for networking, we have VPC, Virtual Private Cloud on AWS. So this specific service is the networking uh, tool that we use to connect all AWS services inside our AWS infrastructure. Maybe we are connecting, we are calling S3 from EC2, or maybe we are executing a Lambda from EC2. So all these, and also maybe there's API gateway. So all these, they maybe there, maybe there can be SQS or SNS services. All these, each and every AWS services are communicated and networked through this VPC. So that's the networking. So CloudFront is also another AWS tool. So we can use CloudFront to deliver our services for the end users, for the customers using CloudFront. When it comes to the security aspect on AWS, we have tools called IAM, Identity Access Management, and also we have Cognito as well. I will explain these later on the upcoming slides. On messaging related things and isolation related things, we have SQS, and also then messaging and notification related things, we have SNS. I will explain them later. For monitoring, we have CloudWatch from AWS, and also there we can monitor what happens on our services, what's the resources usage, what's the allocation, what percentage of resources are being used right now. So we can actually check them using the CloudWatch. So that's about the service categories from AWS. They provide these services: computation, storage, database, networking, security, messaging, monitoring, and many more. Right. So now let's learn some of the important AWS services. So these AWS services will be useful for the today's hands-on exercise designing the metro utility system. So Lambda is a AWS service. So it's a managed service. Lambda we can use to run code without using servers. So as I explained here, if we want to rent a server, we can deploy a EC2 instance, maybe with Ubuntu or Fedora or any Linux instance. But if we don't want to do that, if we don't want to don't want to uh, add a entire server, we can actually run code using Lambda as well. We don't need to um, take a EC2 instance there. So in Lambda, it can run a small piece of code. Um, so Lambda is event driven. Event driven means um, it can uh, it can respond to events. Based on events, it can execute some piece of code, some piece of functionality. And Lambda is also scaling automatically because that's a managed service from AWS. If it gets one request, or if it's getting 10,000 or 100K or 1 million requests per minute, it can handle everything. Per second, it can handle everything. It actually scales automatically. Since it's a managed service, we pay only for the usage. We are not paying for the idle time. And actually, the use case where we need to use Lambda um, is if you need to react to an event, or if you need to handle a request without running a server, you can actually use Lambda there. So that's about Lambda. So then we have API gateway. So API gateway is the front door of the entire house of AWS infrastructure. So it's the single entry point for every app request that passes inside our AWS infrastructure. It handles the HTTPS, the secured HTTP, and it check for the request. It can actually block any abusing related things. It can actually detect, it can handle, it can detect any unauthorized API calls. It can actually handle them. And after doing those security checkups and validations, then it routes the request to the right place, maybe Lambda, maybe EC2. It can does it. And also we can use load balancers as well there to route the requests. And when to use API gateway, so we can actually use API gateway if we need a secure front door for our entire infrastructure. uh, then we need this AWS API gateway to be set up. Then we have DynamoDB. It's actually a NoSQL database service that is provided by AWS, and it stores data records in the same way as the NoSQL database, as a document-based database system. I hope you are aware of the NoSQL databases. It's similar to the MongoDB, and but this is a managed service, so we pay for the use only, and scaling is managed accordingly. So this is since it is a NoSQL database, it reads and writes, and it scales up in the sizes, and it scales up the resources automatically based on the traffic spikes. And it is best for high volume data, and also very fast and simple lookups. The ideal database management system would be NoSQL, and it would be DynamoDB on AWS. So when we can use this, we can use DynamoDB if we need speed and scalable, and if we want simple and fast lookups and fetching data, and if the data is disposable, and if we don't need to stick into the ACID properties, so then DynamoDB would be a NoSQL, and or DynamoDB on AWS would be a great choice. Yeah. Then we have RDS. RDS is a SQL database. RDS is for Relational Database Management System on AWS, so we can manage actually SQL. We can actually create SQL instances, databases there. It can be MySQL, or it can be PostgreSQL. We can create SQL databases with RDS on AWS. It's a managed service, and it supports the transactions as its properties can be maintained because it's a SQL database. So it's best if we want to keep the ACID properties, the atomicity, consistency, and all that. If we are dealing with the money related things, transactions, relational databases would be a great choice. So reach for it when, so when do we need that? Actually, if we need the correct and precise um, maintenance of the records, and other than considering of the speed, then if we are especially dealing about money and transactions, if we are thinking more about, if you are caring more about correctness and ACID properties, then SQL would be a great choice, and RDS is the option we have on AWS. Yeah, then we have Cognito. Cognito is a user identity related service provided by AWS. It handles the sign in, sign up, passwords, handling, hashing, and all that. And also, it can verify OTPs as well for us. It can store our passwords securely, so we don't need to manage them. And it can issue tokens for the authorization and authentication, so that can be done with Cognito. And When we need this when dealing with the user accounts, login and sign in, login and registrations. Then we can actually use Cognito. If you are not developing a login or registration, uh, custom login or registration for our application, we can actually use Cognito, but we need to think about the cost as well. Secret Manager is also a very important tool we have on AWS. If you are very good at software development, if you are aware about the ENV file, environment variable file, in your local setup of any applications you do, so after deployment, after deploying on AWS, the place where we keep the ENVs, environment variables, is the Secret Manager. So we can keep the environment variables, API keys, environment variables such as API keys, passwords, login credentials, all of them securely inside this Secret Manager. So we can remove the secrets from our code base to this layer where it handles the environment variables. So when we need this, actually we need this everywhere, in almost all the applications deployed on AWS, because there are envs we need to maintain. So if there are envs or passwords we don't need to expose to the outside through the code, then we should use Secret Manager to securely keep them. Then we have SQS. SQS is a simple queue service from AWS. It's a message queue. It's kind of following the data structure called queue. Yeah, it's kind of. Sometimes we can select several options from SQS. One option is we can strict into the queue data structure, but sometimes we can select we don't need to rely on that a lot. It would be following this queue data structure, but sometimes there can be anti patterns on selecting that option. But there's option that is right aligned to the queue data structure, so we can switch between those services based on our requirement. So SQS is simple queue service. It's a queue that hold the messages or the events uh, that until they are being processed. So nothing won't be lost before reaching the backend, and it won't slow down your system. Once backend is ready to accept the messages or the events, then SQS can emit those events, and backend can um, call them. And it actually smooths the sudden traffic spikes, because we don't lost anything, because we are keeping everything in the queue until uh, they are responded by the backend. And also SQS is very important when it comes to the microservices. When we want to isolate the services from each other, SQS is a very good option to keep in between those services for the communication in between the services, so we can keep the services isolated. So when we can use this, if we want, if we if the loss of events is a critical thing for our application, if we need to keep records of, if we need to respond to each and every event, then SQS is a necessity. SQS is very necessary and very essential, because we won't lose anything through SQS. SNS is the simple notification service, so we can send SMS, push notifications, emails through this service. It's also managed service and fast service, and one to many delivery uh, from one application. We can actually deliver to many receivers. From one publisher we can deliver this to many receivers. So that's what it called one to many. And when we need this, actually we need this when we want to alert users about some thing happened, or send one-time passwords like OTPs, or maybe sending receipts, sending scheduled emails, SMS. Those things can be managed through SNS. We have step functions. This is a very important one and kind of a complex one. AWS step functions is a workflow orchestrator, so we can manage multi-step processes. Uh, so we can handle multiple states there. It's like a flow chart. We can define that. It can the step functions can remember where the process is, each and every step it can track, and we can rerun each and every step as well. And it has timers also built in, so it can respond if timeout occurs. And that's about step functions. So if there are kind of uh, uh, a flow of states, like maybe payment process, maybe a integration from end to end from one service to another service, and in between if there are many other services, step function would be a great choice to manage the workflow. It actually can manage the entire workflow, so the entire workflow can be supported through these workflow orchestrators. On AWS, it would be step functions. So when to use, we can use this when the processes has many stages uh, and logics in between, and waits, timeouts. So we can use in such scenarios. If the process has many states and many stages, then step function, and if it is a workflow, step function would be a great choice. IoT Core is also an important service, but that is not used a lot on the industry. If it is a purely a software domain, if the domain is IoT related, then this service is used frequently. um, it can receive data from physical devices like scanners, or maybe sensors, and then those sensors and scanners can send the data to this IoT core on AWS. So it can handle the device identity, which is the device, which is the sensor, which is the scanner that send the message or the event. And also it can handle the huge volumes of data, yeah, incoming data as well. So if we are dealing with physical devices that are collecting data for our project, for our application, then IoT core would we would need to use IoT core to facilitate those IoT devices through, and also our application through AWS. WEF is a web application firewall. It's a filter. It's a filter that is kind of is also relay. It's also at the front door of our AWS infrastructure, and uh, it is responsible for blocking the malicious web traffics, SQL injections, scripting related injections, and bot attacks, and those can be um, handled, and we can avoid them through WEF if we have this WEF in front of our AWS infrastructure. Right. And actually the rule sets they are managed, and it's a managed service. And also AWS is updating the firewall rule sets with the latest findings they find related to these security issues. So we are secure in most of the instances if we use WAF. We can use this if our application is facing the public uh, internet, and if it is accessible to the entire uh, users on internet, uh, then we need to keep our application protected against the attacks. So then we should use WAF there. CloudWatch is another AWS service we can use for monitoring. So it is collecting the logs and matrices of our executions, our services, our database, or EC2. So through CloudWatch we can monitor what happens and where and when. If and also it alerts, we can configure the alerts as well with CloudWatch. If there is an issue, CloudWatch will notify us. We can use it if we need to see what happens. Yeah, so we can configure this CloudWatch for the critical places where we need logging to be handled. So that's about the most important AWS services. So now let's move into this building of this e-ticketing system for the Metro bus service. So if I'm not too sure whether you have experience on this service, let me share this simple video. You can see the YouTube video on the screen, right? You guys can see this one, right? Any responses? Yeah, you can see this video, right? I hope my screen is visible.
Yes, sir.
Experience. Okay, okay, great, thanks. So I will just share this video. Let me share the sound as well. Um, I think sound should be there by default. I'm not too sure. Okay. So public transport in Sri Lanka like never before. Here comes the beautiful low-floor luxury metro bus, modern, clean, and super comfortable. Before you even start the journey, just open the LMT Go app and check your route options easily. You can also view the bus timetable based on your location. Stepping inside, the first thing I noticed was the leg space. Honestly, more than enough for a comfortable ride. Once on board, simply tap the QR code and track your journey progress in real time. So that's the most important point here that we care for the session today. So through there's an application called LMT Go, and users can create accounts there. They can register and log into the application. So they have their own QR code. So when entering to the bus at the door, they can scan the QR code on that application to the scanner attached on this bus. So right away that it detects that this particular user has entered to the bus at this bus stop, maybe let's say Colombo Fort, from Colombo Fort. So the system detects that from Colombo Fort the user entered the bus. And when user want to exit from the bus, maybe let's say it's Kadavata. If the user want to exit from the bus at Kadavata, when the bus reaches Kadavata, user can exit the bus, but when exiting he should again scan the QR code to the scanner that is attached on the bus. So by that moment, the system detects, oh, okay, the user entered the bus at Fort, and now it's Kadavata, and uses exiting and ending the journey at Kadavata. And right away, it just detect that, and it's very fast, and also uh, it takes the payment as well through the application. So that's the part we focus today. We will be designing that.
The whole experience genuinely reminded me of traveling in Singapore. Smooth, organized, and efficient. Another cool feature, you can see the live bus location directly from the mobile app. Payment is also super easy. Tap and pay, QR payment, even cash. You can
Yeah, we can actually scan the QR while exiting from the bus, so it will right away take the payment.
track your full payment history inside the application as well. Once you get used to Metro Sri Lanka, going back to a normal bus feels almost impossible.
Yeah, so that's what about the metro bus system. So now let's try to design a simple in AWS infrastructure to facilitate the scenario there. So this won't be the actual uh, infrastructure for this project, okay? So this is based on my experience, based on my knowledge and my experience, and the requirements I understood from the project uh, for this metro bus e-ticketing system, for this metro bus e-ticketing system. So I just did some brainstorming there. What are the requirements that are there in this system? So based on these requirements, I'm defining a simple AWS infrastructure for this project. So this won't be the actual one, and also this can be improved further. This can be improved further a lot. Okay, so since you are undergraduates, and since it should be understandable to you, I will be designing a very simple infrastructure to facilitate this functionality. Right. I hope my whiteboard is also visible. Is it visible? I need some responses from you. My whiteboard is also visible, right?
Yes, sir.
Yeah. Okay. So I need some responses from you as well while going through this. So please try to answer, or please respond from the chat your suggestions. So let's see what are the requirements there. Um, there's applications called LMT Go. Let's say it's the app. I will refer to that LMT Go app uh, here as the app. Okay, app. So what's the requirement? Users should be log into the application. That's the first thing. Users should be able to log into the app, log into the mobile app, right? Log into the mobile app, right? Then we are just focusing for the ticketing part only, right? So there are many other features like tracking, uh, um, uh, what we call adding money or the credits to the system. So those are also there. Top up, yeah, top up facilities also there, but we are not considering them. We are purely focusing on the e-ticketing part. Okay, so the first requirement is what? So user should be able to log into the mobile app. Then when entering to the bus, when entering to the bus, users should be able to scan the QR code. Users should be able to scan the QR code on the application, scan the QR code and scan the QR code and mark it. It should mark the particular user has entered the bus, and mark that user entered the bus. Right, user entered the bus. So when user enter the bus, he scans the QR code. Right away, it should detect that this particular user has entered the bus. Right. Then what's the other case? when when exiting the bus, user should be able to scan the QR code again. User should be able to scan the QR code again. Scan the QR code again. So their system should detect. So their system should detect that this particular user has ended his journey. User has exited, and it should do the payment as well in the same click. It should do the payment as well. It should do the payment as well, right? In the same QR scan. Then after doing the payment, it's very important to let the user know that the payment is successful. So notify user that the payment is successful full, and it should notify that you has it should notify that user ended the journey as well. Here also this user ended the journey. Since user is aware of that one, since he's no, it's like security related improvement. If any other QR code scan would be malicious, or if any if unintentionally if the user touch on the QR code, then it would end the journey. So in those scenarios, handling, user should be know that the status of the journey, whether he is ended the journey or not. So these can be sometimes push notifications. When entering the journey also, it should notify you have entered the bus, notify user. So those are the requirements we see. I hope you understood these requirements. These are the basic requirements, right? Any questions here? Or all good? So what are the requirements? User should be logged into the application, and when entering the bus, user should be able to scan his QR code, and it should notify the user or you have entered the bus. Then when exiting the bus, you should be again able to scan the QR code. Then it should notify the user you have exited from the bus, and also it should do the payment as well, and also it should notify the user that payment also successful. So these are the requirements, right? These are the requirements for this simple system. So let's try to um, capture the important points here. It says a user should be able to log into the mobile app. User should be able to log into the mobile app. So anyway, we have to do some user management, right? We have to do some user management. So as I told you earlier, with which system we can do user management? With which system we can do user management? Mostly if you are relying on AWS. So this is the system. Cognito is the system we can use for that, right? It says we can handle the login on behalf of any custom login mechanism. If you're not developing a custom login mechanism, then Cognito will facilitate us. So here we have this login. So in order to facilitate the login, we can use Cognito. We can use AWS Cognito there. When entering when the user enter to the bus, it should scan the QR code. Okay, it should scan the QR code. So this QR code scanning. I'm not too sure whether the scanner is the device or the mobile application that is responsible. So if the scanner is the responsible device um, for the um, sending the data, then we should use the IoT code. But I don't think, I think mobile application is the thing that facilitates that, because that's the most feasible way. So I don't think we should need IoT code there. Yeah, because that is introducing a lot more complexity. We can handle that through the application itself from the mobile app. Then it does the scan of the QR code, and it marks the user has entered the bus. So user has entered the bus, that's the event. User has entered the bus, that's the event in the system. User has entered the bus. We should not miss this event anytime. Let's say right now the application is accessed by um, 10,000 people. Let's say 10,000 people all around the country is accessing this application in this second, in this minute. So there can be some um, um, uh, uh, so this is like a traffic spy. This is like a traffic spy. So in these situations, sometimes the context can be cancelled, or the some request can be cancelled, or sometimes they can be um, ignored by the server. They will sometimes get internal errors, or they won't uh, execute properly. So we should not let that to happen in this situation, because user has entered the bus is a very important event, because he don't do that again. User has entered the bus, we should somehow mark that, so we should not miss this event. We should not miss this event, should not miss this event, miss this event. For sure we need to execute this event. User has entered the bus. So I told you, describing this one, from which service we can handle these kind of things. Should not lost any events. You see this, we should not lost any events, lost any events. If that's the requirement, then SQS, simple queue service, is the service we need to use there, because it won't um, lose any events. So since this is a very important event, I would use SQS to facilitate this. I would use SQS to facilitate this. And when user entered the bus, okay, we have marked that event. What is the next thing the application should do? It should somehow keep a record. Okay, user entered the bus. User entered the bus at the bus stop. Let's say Fort, at Colombo Fort. And at which time? At, let's say, 4 p.m. IST, Indian Standard Time. Right? So we have to keep this record, because later user should be able to see this in his UI of the mobile application. So we should keep this record. What that means, we have to enter this record to a database. We have to enter this record to a database right away, very fast. We have to handle this. And to save this, what should be the most important one? So since it should be fast, and since it can be handled through a document type, entering and exiting can be handled through one document. There's no more any complexity or relationships, that much relationships there. So we can of course go for a NoSQL service to keep the record of the check-in and check-out to the bus. So the option would be DynamoDB. The option would be DynamoDB. So I'm thinking about DynamoDB. So which should trigger this event which should trigger this CRUD operation, or the creation of the record, the insertion of the record to the DynamoDB. So the SQS would SQS would keep all events. So somehow based on that event, some uh, code should execute this. That means entering data to the database. So to execute some code, some simple code, we can use Lambda. We can use Lambda there, right? We can use AWS Lambda to execute some sort of code, some sort of program. So the SQS, when the SQS event is received, um, the Lambda would be triggered. Lambda would execute this operation. What's that? Entering data, entering this record to NoSQL database. So I will go to the SQS, Lambda definition as well. So here we have Lambda runs a small piece of code when something happens, event driven, based on an event, based on a request. It can run a simple code, right? So it could be a HTTP request handling, or writing data to database, or maybe calling another API. So in our case, it would be writing data to database, right? So I'm thinking that we don't keep any easy to instance. We don't keep any virtual servers. We are just using a Lambda, right? So that's one of my assumptions, right, to make this more simpler to you. Okay, then what's the other thing? Entered the bus, and oh yeah, it says notify the user. When he entered the bus, it should notify the user. So notify the user means once this insertion of the record is completed, we can use SNS, simple notification service, to notify the user. Then we have this requirement: when exiting the bus, user should be able to scan the QR code again. Right, the same scenario again. Scan the QR code, and user is exiting the bus. He is checking out. So this is also event we shouldn't miss. So again, we should use SQS there, simple queue service. Once once the Lambda is ready to execute the message or the event from queue, we can execute the Lambda to again add the record, or the update this particular document record on DynamoDB, that use as exit at Kadawatha at 5 p.m. IST, right? So we can keep that record. So the same scenario is again here, but now we have to handle the payment as well. So right away, after entering this record, since he exited the bus, we should trigger the payment as well. We should trigger the payment as well, right? We should trigger the payment as well. So somehow we should do the payment for the journey he went, payment for the journey. When recording payments, we should uh, we should keep in mind that the acid properties are very important. So acid properties are uh, addressed by the RDS, or the relational databases. So of course we should need SQL databases. So I'm thinking of using RDS there, maybe Postgres or MySQL. So anyway, we will be using RDS to record the payment related things, the transaction handling and payment records, right? So because sometimes the payment can be failed. So in that case, we are handling the payments as transactions. So once every step in the payment is completed, we do the committing. So if there are any failure, we should roll back the transaction. So the best database system that can manage those is the relational databases. So we can use relational databases to handle this payment process, right? And after this payment is also done, again we can notify the user through SNS, simple notification service, and also he has exited the bus, again we can use SNS, right? Again we can use SNS, right? So then what are the other things? Yeah, this is successful. Yeah, now there's an important point here. The thing is, you see, when exiting the bus, there are two events. There are two things we need to do. First thing is it should record the user has exited the bus. So this record should be saved in the DynamoDB, right? So it is a one database management system, right? And then in the same time or parallelly or after recording that, it can be based, it should, it's based on the requirement. So I will assume after recording this, we mark the payment, right? So in that case, we should do the payment as well in the same event. From the same event, we should do the record insertion for the exiting in DynamoDB, and also we should do the payment as well. It's on RDS, Relational Database Management System. So there are two things we need to do, and this is kind of a workflow. This is kind of a workflow. We have to do these steps, and we should be able to monitor what happens on each step. So this has some sort of steps, and we should be able to see what has happened on each of these steps. So this is a workflow. So this is a workflow, right? We should somehow manage this workflow precisely. So this is a very good situation where we can use the step functions to facilitate this workflow. So we can use a step function as well to facilitate the workflow. So we can use step functions as a workflow orchestrator. In most of the cases, like if you are doing a payment and another, um, yeah, and if we are dealing with multiple databases from one step, this step function is a great tool. We can facilitate that workflow. So you see, a process has stages. If there are stages, waitings, timeouts to manage, and in our case, there are many stages. We have to deal with DynamoDB, we have to deal with SNS, we have to deal with RDS. So there are a couple of stages. So step functions, it's a great opportunity to use step functions to facilitate this workflow. So those are the tools I see on this based on this requirement. So now let's try to design the system based on these things, right? The first thing, the user is here, and user has the mobile application. What's the mobile application? LMT Go. In our case, I will just write it as app, because we are uh, doing a yeah, we are doing a clone for that, right? Right. So user does what? So this is the application. This is the application user. Let's see. Here we have the user. Here we have the user, and the user is using the application, right? This application. So what this application does in our case, it scans the QR code, right? So it does the QR code scan, login. It facilitates the login and QR scan, right? So I told you that if our AWS infrastructure is here, the gate for this, the entrance, front entrance would be API gateway. So I will use API gateway here to handle the HTTPS request, and then route the request to the um, particular related route, and also handle the auth tokens as well, right? So I will be using API gateway here as a simple yeah, as a front gate for our AWS infrastructure. And also, since we are dealing with the public, since the general public would be using the applications, there can be situations where attacks would happen to this application. Since we are dealing with the payments as well, right? Money is used in the application. So in that case, in that case um in that case uh, we would need the WAF as well, web application firewall, right? AWS WAF, because it will provide the further security for our application, maybe from SQL injections and any DDoS attacks, any bot attacks. Those things would be securely handled and avoided by the web. So I integrated this to protect our application as well, right? To protect our application, right? So any request that would come to the API gateway, that would be then checked with the WAF as well. So if all good, then the request would be directed to API gateway, and it would direct the request to the relevant service. So from API gateway, it should the first thing should be the system should identify who's the user. System should identify who's the user, right? So to identify the user, we used what? We used Cognito. We used Cognito to identify the user, to validate, oh, he has logged in, whether the password successful. We can use the Cognito, AWS Cognito, right? So AWS Cognito we can use to facilitate this user management, right? So if the authorization and the authentication in this application, basically it would be authentication, it's successful, then it would send the response again, or this is successful. If it is a failure, it would send the response as a failure, right? So based on that, then uh, um, if it is successful, actually the request would be passed to what? The user is checked in, user is entered the bus. So right away user entered the bus, we added that event to what? SQS, simple queue service. I told you, since it's an event, and it's an event we should not miss. Since it's the event we should not miss, we add that to SQS, right? SQS. So this is where, when user check in, when user enter the bus, and when user exit, when user check out. Right away, when user scan the QR code with the scanner, it should add the event to the queue. Then after that, once the service is available to respond to these events, um, the lambda, as I explained earlier, lambda would be the function that would respond to the SQS. So with um, with so see, these are events actually. So events, we have events on this queue. So one by one, those events would be uh, executed by the lambda, right? So we have lambda here, lambda would be here. So lambda would yeah, uh, it identifies whether the scan is done or not. It will check for that. So this would be the scanning processor. It is check whether it is check in or check out, whether it is check in or check out. It will check, validate that. Then we would start the workflow. We would need to start the workflow to enter the data to DynamoDB and RD. So Lambda would be the service that would trigger the workflow. So we have the step function. So we have the step function here. On the step functions, we can define multiple steps for the workflow. If they are parallel, we can define that as well. If they are sequential, we can define it in the sequential way as well. So for now, I will assume that as a sequential process. Yeah, I will just try to take this to bottom. Yeah, right. So on step function, so what are the things we need to do? We have marked there. We have wrote them there. Yeah, what are the things we need to do? We have to keep the record. User entered the bus, right? And we need to send the notification. So that's the first scenario. So we use what for that? We use the DynamoDB. So step function would call the DynamoDB, the NoSQL database, DynamoDB, the NoSQL database. So it will record the uh, check-in and check-out records, right? Check-in and check-out records, check-in and check-out records, check-in, check-out records. So where user entered the bus, where user exited from the bus. So those records and the timestamp, those things would be stored on DynamoDB. If user check-in first, then it would store the record as the open trip. Open trip means only the check-in is there. If checkout request also came and entered the data to the database, then it would be a closed trip because user has ended the journey, right? So these open and closed trips can be managed. Those records can be managed through this DynamoDB as document records, right? So we use that there. So after that, if that saving the database record insertion is successful, then again the responses come to here 200 or 2k. Let's say 200 or I will say 500 response. Okay, success or failure, right? Success or failure. Based on that, it will trigger the next one. What's the next one? It will trigger the SNS service. You remember, right? Simple notification service. So simple notification service in SNS, we can configure um, the messaging system. So it will notify the user. It will notify the user. It will notify the user that he has entered the bus, right? Or he has exited from the bus. And in the next checkout scenario, now again user is do the QR scan. So system will check for the AWS web if check whether the request is secured. If that is done, then request would go to the Cognito to identify the user. Then once the user is also identified, it marks the checkout. So checkout is also an event that we should not miss. So we enter that to the SQS, and then Lambda will consume that event, and Lambda will identify, oh, this is a QR scan, and then it adds the request to the step function. So in step function, it would we can define steps, multiple steps there. On this step, is this check-in? If it is check-in, do this. If this is checkout, do this, right? So then here, so we can define multiple steps on this step function. I'm just describing this very high level, right? Because I know majority of you won't be I think you are not aware of these things. I just want to give you guys a high level understanding. That's why I'm describing this. So step functions, we can define our workflow in many steps. We can have logics here. it's like a flow chart. So if yes, if this is true, do this. If this is false, do this, right? So those way we can define the workflow. So in checkout scenario, what happens is, in checkout scenario, step function. The first thing would be we should close the trip document. Uh, from the check-in, it was an open trip. So once the checkout event also triggered, it should close the trip. It should close the trip. So the document would be updated in the DynamoDB related to that user's that specific trip. So it will record this user exit from the bus at this time at this bus stop. So those record would be updated here. And also in the same time it should do the payment as well in the in the exiting, right? So we should integrate, we should use RDS also here. So RDS, we have the relational database management system. So this will handle the so the step function payment step would handle this payment process. It would be um, recorded on the RDS. It would be recorded on the relational database system as a transaction. So if it is successful, then response would be come to here. Fail, if it is failed, that's the failure response also would receive to step function. So the payment related details, what happened to the wallet balance, and also the payment payment amount, those would be recorded on the RDS, right? Then based on its response, if it is also success, then again what we need to do, again we need to send a notification to the user notifying that the payment also successful, payment also successful, payment also successful, right? Payment also successful. So that is the scenario, the high level, very high level architecture for this typical system based on the redefined uh, requirements by us, right? This is a very high level and very simple architecture. So we can actually improve this further. And also probably the use of lambda won't be that much used in some cases because the application would be deployed on EC2. So there can be servers, so there are many differences. So this is the way actually I wanted to describe you, teach you many services through one system. So that's why I actually used the almost all the related services here. So you will be aware of these things, at least you hear these words so you can search about them later, or else you are aware of these things so you can refer to them later, or else if you are working, you when you hear these words or hear these tools, you will remember, okay, this is the use of this tool, this is the use of this tool, by that way, right? Basically the one more thing on this step function, the how these step functions work. In the step functions we can define the workflow, we can define the workflow, right? When check-in, do this, right? After updating DynamoDB, then the rest, this is the DynamoDB update. So if that is done, then notify the user SNS, right? If checkout, so this is the check-in scenario. If checkout, then it should be something like this, right? And it when when the response received, right away it again do the relevant logic on RDs, the insertion of the payment details, the payment processing would be handled. So this is like a flowchart. The step function defining is like a flowchart. There are several steps. Each step we can define the things we can do, the where which service to call, which logic to execute, and what's the rollback mechanism. Those things we can do in this step function. It's like a flow chart, right? I just want to give you guys some heads up there. So this is the very simple thing. And also I told you about the monitoring as well, logs and monitoring. So we would need monitoring in critical places, right? What are the critical places here? What are the critical places? So the scanning is successful or failure, we would need to actually uh, monitor. So we can configure CloudWatch there for this particular lambda, and also whether for the step function as well, whether it inserted the record to DynamoDB, whether it inserted the record to RDS related to payment, whether the payment is successful, whether the notification sending is successful. Those also would be great if we can monitor, if we can check the logs for that. So we can configure this CloudWatch, the monitoring tool as well, in these places, the critical places, right? Yeah, so that's what I wanted to share. So about this designing, yeah, so this is the my suggested way. So actually this won't be the real case. I wanted to teach you many tools and use those many tools to one system. That's why I came up with this design. Right, so there are many issues on this design, and we haven't addressed some of the uh, concerns as well. So what, for an example, what if the user mistakenly unintentionally scan the QR code? He would be checkout, right? But he won't need to, he probably don't want to exit from the bus. So we need to help those things. So many things are there, right? So in this case, this is the sample design I came up with. So in order to design such a system, what you need to do, you need to be aware of the AWS services like Lambda, when to use what. That's the thing. When to use which tool, where to use which tool. So you should have that knowledge. So with having that knowledge, you should consider the requirement from the customer when developing a system. You should um, you should design it based on the requirement, right? Refer to the requirement of the customer. So based on that requirement, identify where, when to use what, when to use which AWS tool, or when to use which cloud tool that you need to do, right? Maybe it's Azure, or maybe it's AWS, or in AWS. So when to use which tool. So that's the thing you need to plan. So as the plan I did here, you see, I just wrote the um, wrote the requirement, and based on that requirement I tried to capture the important things, and then I facilitated those things with the AWS tools, and finally I came up with the design, right? That's the way you should proceed when doing the things, right, when developing a software. So so you should be aware of the tools, you should have the knowledge on them, and you should be knowledgeable on when to use what. So then based on the requirement you can design a system. And one more thing, when you are dealing with AWS services and all, and also maybe Azure or any other cloud service, those are sometimes very costly, right? So you should define a scalable system, and also you should define a cost efficient system, cost effective system. Okay, so sometimes very simple application can cost for thousands of dollars. You should not let that to happen. So you should master the knowledge on these things, to utilize the resources, utilize the services, AWS services, to reduce the cost and optimize the performance. So there are many things: optimize the performance, resilience, right? So and and you should also be mindful about the cost as well. So that's what I wanted to share during today's session. So yeah, that's it for the session for today. So if you have any questions, you can raise them now. Any questions? All right, you have submission, right? Slido. Let me join that. Yeah, so we have, so let me share the screen so then you would see the questions. Yeah, great, thanks. You are sharing, right? Hmm. Okay, so there are a couple of questions, so I will ask. Uh, what skills do companies expect from undergraduates applying for cloud related internships? So if you are an intern, if you're looking for an internship, so the best thing is you should master the basics, right? Basics means you should be proficient, and you should have some skills on programming, right? You should know the database concepts. Don't think about the cloud related word for now, right? Don't think about the cloud related word for now, because cloud engineering is a subsidiary, is a kind of extension, or the yeah, it's a kind of extension of software engineering. AI engineering, cloud engineering, DevOps, QA, site reliability. Then what are there? ML, AI. Yeah, yeah. Those are the DevOps, cloud. Yeah. So from all of these job categories, or the jobs, or the opportunities, software engineering is the kind of the base, right? So you should master the software engineering concepts when you are applying for an internship, no matter if it is a cloud based internship, no matter it is a DevOps, no matter it is a site reliability internship, no matter it is a AI internship. First thing they will ask from you is the basics. You should know about version controlling. What's Git, how to do commit, how to clone, how to commit, how to stage, how to push, how to check out from branches. Those things you should know, right? And then you should have knowledge on arrays, queues, stacks, the basic data structures. It is good, it is good if you can study about the hash maps and those things as well, the complex data structures. So you should have knowledge on data structures, and you should have knowledge on the arrays, those things, right? The basic programming questions you should be able to answer, right? Maybe like how program is executed, right? How the garbage collector works, right? How this, what's asynchronous programming, what's synchronous, so those things. And probably you will receive a programming question, maybe swap some numbers, order array, those things. So you can check for the, what you call the, there are hack uh, I can't remember the lead code and those things, so you can practice those questions there. And so the first, database, yes, very important. You should master the database concepts as well. What is, why SQL, why relational, why non-relational, when to use relational, when not to use relational databases, what are ACID properties, what are transactions, what are views, right? So you should be able to write some queries, basic queries, right? You should be able to answer the query optimization, right? The things you learn as an undergraduate, right? And then you will ask about, after answering all those basic software engineering questions, then they will ask and also OOP concepts. I missed that, OOP concepts, like things, right? So after answering all those basic questions, then they will they will check your cloud related knowledge, right? So if you fail answering those basic questions, you won't um, um, come to the stage where they ask for the cloud related questions, right? So the first thing you need to do is master the basics, right? Master the basics. That's the best that's the first thing you should do. And when it comes to cloud related internships, they will ask for what is cloud, and what are the cloud services you have worked on, right? And if it is AWS, they will ask for some simple things like what is EC2, what we can do with EC2, and what is SQS, what we can do with that, and yeah, what is load balancer, right? What is ECR, right? Those things. If it is AWS, they will ask for those simple things. So um, so the first thing is you master the basics, what you learn in what you are learning on the modules of the university, from the university. So master those things, then do some side projects. They will ask for a project you did, so you should be able to answer that, how you handle those things on the project, right? And then if you are deployed the application on cloud, then that you should be able to answer that, right? So deploying applications, try deploying a simple application you have built. So probably you have built many projects during the university first and second year, right? So you can try deploying them. So for AWS and Azure, you can create an account there. So they usually provide 3 months to 6 months, 3 months or 6 months trial period. So in that period of time, you can try out many things. You can set up tools. They won't cost anything because that's a trial period. So once ending the trial period, you should switch off, or you should down all the configuration you do. If not, they will cost you. But what I suggest is master the basics, then move into the cloud related things. Try to deploy a simple application. Try to explore the tools on the cloud. So yeah, so you will be able to get the internship there. Yeah, first thing is basics. That is the first thing. Besides of AWS, what are the technologies should we learn to become a cloud engineer? Yeah, you should learn. You should be aware of the basics. That's the first thing. Basic programming you should be aware, and also the CI/CD related things. You should have some sort of knowledge there. How deployment pipelines work, how continuous integration and deployment works, how these pipelines work, how the Dockerization and Kubernetes clusters like things work. This is not for the internship related thing. Okay, if it is not AWS, if you are going forward for Azure, then you should know about the Azure services, Azure database, what tool we can use to host a database there, right? So those things you need to have some knowledge. um, um, Cloud engineering actually it should have the basic software engineering knowledge, and also the cloud related deployment related knowledge, and the knowledge that I explained here, uh, the designing related things. So that means the knowledge about AWS tools, and load balancing related concepts, and load balancing related concepts, and yeah, deployments, and also the security related things also you should be aware. Cloud engineering, if you are going to be a cloud engineer, how to secure cloud services, how do you secure cloud infrastructure, how to optimize your cloud infrastructure. So those things you should be aware. You should study those things as well. Yeah, that's it, I think. So since you are undergraduates, try to master the basics. Then after mastering the basics, explore the others. That's the thing you can do. So and also There are some practice playgrounds provided by many tools. Recently, I saw a tool called Code Cloud. So in Code Cloud, um, Code Cloud, there's a site there. So there you can actually play. They have set up some playgrounds for DevOps, cloud, and all those things. Code Cloud, yes. No, not GitHub.io, Cloud Cloud. Uh, uh, yeah, uh, Code Cloud, right? So let me code. Yeah, this one. So you can actually go to this site. There are many playgrounds. There are many challenges you can take. 100 days of DevOps, 100 days of cloud. So this is a very good one. You can start your cloud journey with this one. There are many practice questions. So while working on these exercises, there are like I think 100, yeah, 100 tasks there. So you can complete them on 100 days. That's their um, um, plan defined here. So you can go to this code cloud and try this 100 days of cloud, 100 days of cloud competition, the challenge. AWS and Azure both they are facilitating. So you see, right? So this VPC EC2. So you can learn about the entire flow, right? So please try out this. I'm suggesting this because I did the 100 days of DevOps there up to some level. Some part is yet to complete. So that's a very good challenge. 100 days of DevOps as well. So you can try this one. 100 days of cloud. I suggest. I can recommend this. Yeah. If you have any questions, please reach to me on LinkedIn so I can support or answer any questions there. Yeah. All good, right? Yeah. So I think we can end the session. Yeah. Organizing team. Yeah. Over to you.
Thank you very much, Mr. Anjanna Pathirana, for that insightful and engaging session. Your clear explanation of cloud computing fundamentals, along with the practical system design example, has given us a better understanding of how cloud technologies power modern applications and solve real world challenges. We truly appreciate your sharing your knowledge and experiences with us. Since we have concluded the Q&A session as well, thank you everyone for your active participation and thoughtful questions. On behalf of the IEEE Women in Engineering Student Branch Affinity Group and the Ingenuity 3.0 Organizing Committee, we would like to express our sincere gratitude to Mr. Anjana Patirana for generously sharing his valuable time, knowledge, and expertise with us. As a token of our appreciation, we are delighted to present our certificate of appreciation. Thank you once again, sir.
Thanks a lot. You all are welcome, and thanks for inviting me for the session. It's a great pleasure to, yeah, um, do a session for the you guys. Yeah.
Before concluding today's session, let us capture this memorable moment together. I kindly request everyone to turn on your cameras. The virtual background has been shared in the chat for those who wish to use it. And guys, again, I would like to invite you all to switch on your cameras and use the virtual background. Ready, everyone? Three, two, one, smile. Thank you, everyone. We truly appreciate your participation.
Thanks, guys. Bye.
To formally conclude today's session, I would like to invite Shalini Bangamuge to deliver the vote of thanks.
Good evening, everyone. As we come to the end of the today's session, it's my pleasure as the co-chairperson of this project to deliver the vote of thanks for the second session of Ingenuity 3.0. First of all, on behalf of the IEEE Women in Engineering student branch of the University of Moratuwa, I would like to sincerely thank our guest speaker, Mr. Anjana Patrana. Thank you for taking the time to be with us today and for sharing your valuable knowledge and experiences. Your session was truly insightful and we learned a lot from it. Next, I would like to extend my heartfelt thanks to our project directors for their continuous guidance and support throughout this project. Your encouragement and leadership helped make this session a success. I would also like to thank my fellow coaches and the entire organizing committee for your dedication, teamwork, and hard work behind the scenes. This successful session would not have been possible without each and every one of you. Finally, a big thank you to everyone who joined us today. Your participation and support mean a lot to us. We hope to see you again in the upcoming session of Ingenuity 3.0. Thank you all and have a wonderful evening.
Thank you so much. Bye.
Thank you, Shalini Bangamuge. Thank you to our esteemed speaker and to each and every participant for joining us today. We hope today's session has strengthened your understanding of cloud computing and inspired you to explore the exciting possibilities of designing scalable solutions for real world applications. Once again, thank you for being part of Ingenuity 3.0. Have a wonderful